Okay, hello, BC Part 1. How are you? In this screencast, you'll notice that there are two parts to the homework. To watch this screencast, and then the homework is going to be from the attached PDF. Okay, so I want you to print that out, print those out, the PDF out, and then I'll be drawing from questions there. Okay. So this screencast is going to be a review again of function domains, domain restrictions, etc. Okay, and as I keep saying, one of the things that you'll notice is the kind of deliberate weaving in and out between trigonometry and not trigonometry, or I guess we can call it the pre-calculus or the algebra of functions, if you will. Okay, so in this screencast, this will be mostly a reinforcement of that which you've seen before. So let's begin. Okay, so the first thing I want to begin with are these two the two cardinal laws that must not be violated within the realm. And right away, I kind of sound like that could have been an introduction to some fantastic fantasy novel, but it's not. These are two cardinal laws that must not be violated within the realm of real numbers. Okay, and those two cardinal laws are division by zero and the square root of a negative number. Okay, so we can never divide by zero. And we can never take the square root of a negative number within the realm of real numbers because division by zero is undefined and the square root of a negative number is undefined as well. Okay, so those cardinal rules are division by zero and the square root of a negative number. Okay, the square root of zero is zero, so that is doable within the realm. But within this realm, the square root of a negative number does not exist, and division by zero is undefined. All right, and if we kind of just start with these two cardinal laws, this first exercise here is going to be fairly straightforward. So let's take a look at several functions. Let's take a look at let's see. Let's say f of x is equal to 2x all over x squared minus 16. And let's do this. Let's say g of x is the the square root of 4 minus x. Okay, and so let's first ask this question: what is the domain of f of x? Now, what's interesting here is we have talked about the domain of a function this year graphically. Okay, we've looked at a graph and determined its domain. We've looked at a graph and determined its range. What I'm going to do here with f of x and g of x is determine the domain of these two graphs algebraically, which means just looking at the nature of the algebraic makeup of the function and determine what it is that x cannot equal. Okay, what value can x not equal? Well, let's see. I mean, maybe some of you will remember that division by zero, well, not remember, you've just been told above about two cardinal laws that must not be violated within the realm. You may remember that f of x, 2x over x squared minus 16, you may remember that that denominator is factorable. Okay, this is a difference of squares. And you may remember that factoring a difference of squares, a squared minus b squares, factors as a plus b times a minus b. And if you look at this denominator here, division by zero, the values of x, if x equals 4 or negative 4, division by zero occurs, and therefore this expression and then the function would not exist. So right away, the domain here is such that x cannot equal 4 or negative 4, okay? Or x cannot equal positive or negative 4. But otherwise, x can be any other number. X could be 0 because 0 divided by a number is 0, okay? There is no other number that would violate one of those cardinal laws of the realm. And when you say the domain x cannot equal 4 or negative 4, the implication here when you write this, it is implicitly understood correctly that when someone says x cannot be 4 or negative 4, you are also saying that x can be anything but those, okay? Which then leads to the range. Well, the range is sometimes less obvious to see immediately because the range, to see it, you're not looking for a violation of one of our cardinal laws of the realm, okay? With the range, you're looking at, let's take a look at this. Y equals some function, right? Y equals a function that really, if I simplify it, is just some numerator divided by some denominator, okay? And if you think about dividing two numbers, which is essentially what this is, if I divide two numbers, can I get 0? Yes, 0 divided by 17. Let's see, if I divide two numbers, can I get every possible positive number? Yes. If I divide two numbers, can I get every possible negative number? The answer is yes. So the range here is that y could be all real numbers, okay? There is no value that y cannot be because there is no value that cannot be the result of dividing two numbers, okay? How about the domain of g of x over here? Domain of g of x, what do you think? Go ahead and try and think about this and then replay me to get the answer. Well, the domain you see here, the domain we look for a violation of a cardinal law of the realm. So I'm taking the square root of 4 minus x. Well, and I know that 4 minus x must be a number bigger than 0, okay? Otherwise, if this radicand is negative, the square root of a negative number does not exist, not at least within this realm, okay? And when I solve this inequality, what I get here is that x has to be less than 4, and this is my domain. So for this square root to be able to be taken, the value of x has to be less than 4. Now, what I noticed here is, I'm greater than or equal. I know greater than or equal to 0. Yep. So x is less than or equal to 4. Bye, Eric. Are you all set?
Yeah.
You're good?
I solved it.
What happened?
So.
Did you figure out what was the stupid mistake?
No, I just didn't. It was like z.
Oh, that's so silly.
So
yeah.
I put it in.
Yay!
I solved it on the calculator. Yeah.
Yay!
I got it.
That's awesome. Okay, now here's the thing.
That's what the job made.
When you oops, I didn't pause my screencast. Pause. Okay, so here's your domain. What do you think the range is? And again, the range, you're not necessarily looking for a violation of a cardinal law. The range you're looking at here, it's the square root of a number. Okay, the square root of a number. Could the square root of a number be negative? No. Could the square root of a number be 0? Yes. And the square root of a number could be positive. So here the range is y is bigger than or equal to 0. Okay, so when you're finding domain and ranges, think about those two cardinal rules, and then think about the values of x that would violate those cardinal rules. And then for the range, think about the operations that are happening here. Okay, how about this one? What about this one? Let's say determine the domain of this. Okay, let's see. Oh gosh. Oh goodness. Oh well, okay. Of f of x equals x cubed plus 2. Okay. And sometimes you'll see asked of you, find the natural domain, okay, of a function. The natural domain means the domain of a function within the realm of real numbers. And hopefully you're wondering, what is an imaginary number? What's a non-real number? And I will answer those questions probably within a month, okay? So determine the natural domain of f of x equals x cubed plus 2. Go ahead and try that and then play me for the answer. Well, here, interestingly, the domain is x can be all real numbers. there is no value of x that would in any way violate one of those two cardinal rules. Okay, you can in other words, you can take the cube root of any number. Well, how about the range? The range is also all real numbers. Okay, I mean, maybe you're wondering, oh, could y be 0? Yes, y could be 0. If x equaled the negative cube root of 2, right? If x was the negative cube root of 2, when I plugged in x, that would give me negative 2 plus 2 equals 0. All right, and you can kind of play around with that idea more. If I plug in, there are values of x that I can plug in that would give me an output of y that is positive, right? There are values of x that I can input that would give me an output of y that's negative. There's a value of x I can plug in that gives me an output of y that is 0. Okay, very, very, very good. Okay, let's see. Let's just make sure that you remember things like this. Let's use this same function here, okay? Can you find the following? So that first part of the screencast is about determining the domain and the range of a function without the graph, okay? Without a graph, determining the domain and range by looking for violations of cardinal rules, and then looking at kind of the operations involved. Let's see, using this f of x, find the following. What does this mean? If I say find f of 3, f of 0, f of t plus 1, okay? All right, let's do f of 3 together, okay? This is function notation. And f of 3 is saying, in the function f, please input 3 in for the independent variable. And f of 3 will equal what? Well, let's see. F of 3 will equal 3 cubed plus 2, which equals 29. So f of 3 equals 29. Okay, which means, let's make sure we remember what this means. If you see in function notation f of 3 equals 29, what that means is the point 3 comma 29 is on the graph of f of x. Okay, what is f of 0? F of 0 equals 2. Okay, what about f of t plus 1? Go ahead and do this one. See what you think that's going to be. See if you can think about how to proceed through with f of t plus 1, then reply me for the answer. Okay, well, f of t plus 1 is saying I should hook my t. Okay, in function f, please input t plus 1 wherever I see x. Okay, well, f of t plus 1 will equal x plus 1. Ugh, yeah, come on. T plus 1 cubed, because t plus 1 is being substituted for x, right? Plus 2. And I guess if I really felt like simplifying, I could multiply this binomial out, cube it, and then add 2. I'm not going to do it, though. So here is f of t plus 1. Okay. Okay, and let's see, let's ask another question. With that same f, f of x equals 0 at x equals question mark. Okay, again, this should be a comfortable review. If I'm asked this question with, again, the function f above here, let's see. This is saying f of x equals 0 is saying y equals 0 at x equals question mark. Well, let's see. If f of x equals x cubed plus 2, we're saying 0 equals x cubed plus 2. Negative 2 equals x cubed. So the cube root of negative 2 equals x. By the way, the cube root of a negative does exist. Okay, you can take the odd root of a negative number. That does exist within the realm. Okay, even roots do not. All right, very good. Lovely, lovely, lovely. Let's see. Let's making sure we just cover all things here. Okay, let's do this. Let's say example number 2, let f of x equal square root of x minus 3 and g of x equal, I don't know, 1 over x. Okay? All right. Find the following. A. F of x plus g of x. And then let's do this one. Find f of x times g of x. And C, let's find f of x divided by g of x. Okay? All right, well, let's see. So f of x plus g of x, this would equal f of x plus g of x. F of x plus g of x is saying, take function f, take function g, and add them. Square root of x minus 3 plus 1 over x. That's it. This is f of x plus g of x. Now, notice something, okay? F of x plus g of x is just a new function. It's just some new function of x. I mean, and some people even will say, like, I'm going to create a new letter, and I'll call this the function h, okay? I have a question for you. What is the domain of h? And what's the range of h, of function h? Okay? Sometimes textbooks will take kind of a shortcut. I don't like this. But see how we write f of x plus g of x? Sometimes texts will do this and just say like f plus g. I don't like it. But that's just me. I just think it's a little bit sloppy. And not sloppy, I just think it's unnecessary. It's just like, I just don't think it's necessary. But anyway, you may see that. Okay, let's go ahead and do B. Go ahead and do B. What is f of x times g of x? Well, f of x times g of x will equal the square root of x minus 3 all over x. And f of x divided by g of x will equal x times root of x minus 3. Okay? And actually, what I'd like you to do for all 3 of these right here, go ahead and find for all 3 of these new functions the domain and range of each. Domain and range of each. And then replay me for the answers. Great. Take a look over here. Okay. So the first one, f of x plus g of x. Notice here, the domain here is x is greater than or equal to 3. Now, I wonder how many of you wrote this. How many of you wrote x can't equal 0, x is bigger than or equal to 3? And let me ask you a question, okay? If you wrote these 2 down, I'm going to say your domain could have been cleaner, okay? X has to obey both of these conditions. X has to never equal 0, and x has to be bigger than or equal to 3, right? So there is one of these conditions includes the other. In other words, if x must be greater than or equal to 3, then x won't equal 0 anyway. So this is the domain. This range was really interesting. Okay, you think about it. It's like, oh, interesting. If x can only be 3 or greater, let's think about this. X can only be 3 or bigger. Okay, that means the square root of something, this portion is only going to be 0 or positive. You understand? 0 or positive. When x equals 3, this is 0. All right? When x equals 4, it's 1, so on and so forth. Okay? Now, this value, 1 over x, okay? When x equals 3, this equals 1/3. I just actually accidentally hit pause, okay? And what you're probably thinking is, but interestingly, Ms. Yam, as x gets bigger, this gets smaller. Yes, I agree with you. This is true. As x gets bigger, this does get smaller. But what's interesting, as x gets bigger, this part gets bigger. In other words, this part gets so much larger, and this part gets more and more small, gradually approaching 0, which means that something getting bigger and bigger and bigger plus something getting smaller and smaller and smaller. If I were to ask you here, as x gets bigger, who overpowers the other one? Yeah, this one overpowers this one, okay? So when x equals 0, this whole expression equals a third, but as x gets bigger and bigger, y just increases from there. I love this one. This was really fun too, okay? The domain here is x is bigger than or equal to 3 for the same reasons over here before, okay? So yes, I know x can equal 0, but saying that x is bigger than or equal to 3 will satisfy this condition as well. And this one's interesting. You know, what is the range? The range in this one would be what? Well, this is interesting. So here, notice, when x equals 3, the whole quotient equals 0, okay? So the y value starts at 0. And then, as x gets greater and greater and greater, this quotient gets bigger and bigger and bigger, okay? And here is my domain and range for the last one. Okay? Very good, very good, very good. Let's see. I believe that is it. So your homework after this screencast, okay, you are to look at that handout that's attached as a PDF. And on the top page, which is, okay, on the handout, okay, the top page says page 13, the second page says page 25. So on page 13, please do the following. 7a, all of 9, 11, 19, 24. Okay? Second page, second page, second page, second page, which is, it says page 25, but okay? 27 and 29. All right? Bye.